Welcome to APA's weekly webinar. My name's Billy Zadek, Manager of Special Projects for APA. Just a couple of housekeeping items before we get started. The webinar recording will be posted to the APA webpage later this afternoon. You'll receive a follow-up email in the next couple of days with a link to the webpage where all webinar recordings are housed, as well as a link to our upcoming webinars. We have webinars planned out through the end of 2021, and many are open for registration. Professional continuing education and AIA-CLU credits are being offered for today's program. If you are an AIA professional requiring a certificate, please send an email to me at Billie, B-I-L-L-I-E, @APA.org, along with your AIA membership number if you have not done so in the past. All attendees are in listen-only mode. Please type your questions in the chat box and they will be answered in the order they are received. If we run out of time and we still have questions, responses will be sent directly to the person asking the question by one of our presenters. If you're just calling in, make sure to send me an email at billie@apa.org so I can send you a certificate if you requested one. The system only recognizes you if you log in. At this time, it's my pleasure to turn this over to Jane Geyer, who will introduce our speakers for today. I will rejoin you for the Q&A session later. Jane, take it away.
Thank you, Billie. I have the pleasure of introducing our panel for today. Before I do that, I'd like to remind the audience that the panelists' participation in this webinar does not imply an endorsement of the ETC group. At first, I'd like to introduce April Guyman. April's a mechanical engineer and a PE. April created and directs our monitoring-based commissioning group. Her engineering team is responsible for translating data into actionable projects for building owners, which is what Jim and Josh will talk about with you today. April is a recipient of the Consulting Specifying Engineers 40 Under 40 Award, and in our webinar today, she will introduce the concept of monitoring-based commissioning. Next on our panel is Jim Saka. Jim was a student at BYU, graduating in electrical engineering. He spent 15 years in the controls industry programming HVAC systems before returning to BYU, and now he serves as Director of HVAC Operations, Maintenance, and Analytics, which is kind of a cool title. In his years in the industry, he's always wanted to use data to drive maintenance and repairs. Finally, at BYU, he's created such a program, and he wants to share with you how he got it started. And our final panelist is Josh Lathy. Manages 20 properties on the University of Utah campus. Originating from a carpentry background, he's grown his skills to all aspects of facility management. He's also developing a culture of data-driven decision-making and is self-admittedly willing to go down the rabbit hole for resolution. Josh is going to give some key examples of how data solve lingering building performance issues that no one could figure out. And I'm Jane Geyer. I'm a principal engineer at the ETC group and an advocate for how monitoring-based commissioning is improving our industry. With that, April, I will turn it over to you.
Thanks, Jane. Okay. Okay, so I would wager that many people on the webinar have been through a recommissioning project of some sort on your campus. And some years ago, I remember going through these types of projects and being so excited that the savings were achieved and the goals were reached. But every time I'd walk away and the team would walk away, a little piece of us would know that some of those hard-earned savings would degrade. And that's drift. That's just the nature of things. Whether you do a project or don't do a project, buildings tend to move towards a less efficient state without a lot of effort put into them. And when new technologies finally hit our industry, like big data analytics softwares, it became really clear that these technologies, these new softwares, are really what can change the drift story and offer so much to building facility teams. So I want to walk you through this graphic quickly. So this graphic represents energy use on the y-axis and time on the x. And you can see this blue line is an event like a recommissioning project, some kind of focused effort to reduce energy in a building. And if we do nothing and we walk away, this red arrow represents the potential drift that can happen. Also, I've never been so stressed about what color to use in a presentation with BYU and the University of Utah here. Don't read anything into the colors that I've picked, okay? But this drift is like, this is what's typical. And what we've learned over time, and a lot of learning lessons learned, is that if we take some of these new analytic technologies, these new softwares, and apply them during our project, we can achieve this orange line, which is even deeper savings during the project. And then instead of a red line taking us back up in drift, we can actually, through monitoring-based commissioning after the project and continuing, we can achieve this purple line, which not only preserves the savings of the project, but also continues to drive into deeper savings and better performance of the building. So this whole green shaded area really represents the value from an energy perspective that we can get out of monitoring-based commissioning. And I'll talk in just a minute about what is monitoring-based commissioning. But this is the why. This is why we want to do it. And then also there's a lot of benefits that can come outside of energy. There's a lot of things that are really important, I think, to everybody here beyond energy, like comfort and safety of your environments. Those are all things that can also benefit from monitoring-based commissioning. Okay, so I'd like to give you a quick sense of what these monitoring-based commissioning softwares can look like. So you'll probably hear a lot of different terms like analytics or monitoring-based commissioning software, or FDD, which is fault detection and diagnostic. That's a really common term that you want to know. All of these represent a single software platform where all of your data can come into a single place, which right there is just super appealing. All of those different building automation systems that you might have across your campus can all be centralized into one place. All of that data can be viewed without having to log into a lot of different data sources, which in and of itself is just really cool. These softwares then, when you bring in those data sources, so all of those, all that information from your building automation system, they go through what are called rules. Well, let me first say, when they come in, when we bring them into the software, they first get mapped and tagged. So they get mapped in a sense that everything is organized so that we know that this VAV box is connected to this air handler, and then this temperature sensor is part of this air handling unit system. So everything's clear on how things are connected. And then also that information gets tagged so that we know that this discharge air temperature sensor is a discharge air temperature sensor and not some other kind of temperature sensor. And once the system is clear about what all these pieces of data are, they get run through rules. So rules are condition-based algorithms. So they're essentially math equations that have been set up to find inefficient operations. So for instance, if we have a chilled water valve and the command is saying it should be closed, but then we see a temperature drop across the coil, that's an indicator that there might be a leaking chilled water valve, and we can see a fault come out of that rule. So faults are really important to find. I mean, when you have so much data streaming into your platform, into your systems, it's really hard to manually go through and find all of those discrete problems or inefficiencies that are happening. So that's what faults can do for us. There are also tools in these softwares beyond faults. So there's things like regressions for baselining, comparing previous performance, dashboards, or other tools that can help really bring more complicated problems that can't just be reduced into a simple math equation, bring those problems into a bigger picture to be able to find the inefficiencies and the issues there. Another important function of these systems is to provide some really clear way to show the results, because if you can't have action and go make resolutions and make the fixes, then there's no way we're really going to get actual value out of the software. So some way to see those results is really important as well. I also want to highlight that the reason we want these softwares, I mean, this is things that a really good engineer can go through and find these kinds of issues, or your facility teams that are really good at this stuff could probably find a lot of these issues. But when you have an entire campus or really large facilities, we have our biggest facility that's connected has over 1,600 terminal units in one building. there's just no way practically to go through and manually find all these kinds of issues. So there becomes really high value created with using these softwares. I'm not going to go through these, but this is a list of essential, just some of the rules we use all the time for air handlers, central plants, and then I've got highlighted here the terminal units where, you know, just so many pieces of equipment, it's really useful to use the automated software to find these issues. Okay, I want to walk you through a couple of examples of faults and how they work. So I kind of talked through this one a little bit, but I want to give you a more clear example of how this is working. So here we have an air handler with a set point of the supplier temperature, that's this green line, and a blue line representing the mixed air temperature coming into the unit. And then this red line represents the supplier temperature that's provided by that unit. And you can see that the supplier temperature in this first half of the graph is not meeting its set point at all. And its chilled water valve is closed, but somehow we're seeing this big temperature drop from this mixed air to the supplier. So this is where we can see a fault being flagged by the software. So here is this little orange block here represents the fault that's being detected. This is not operating the way that we would expect it to. So we took this back to University of Utah and their team. This is an example from them. And they were able to go and troubleshoot the valve and identify that the actuator was broken. It wasn't working anymore. So they were able to replace that. And here you can see right when they replace it, we get better control of the unit. We're actually delivering the temperature that it wants. And the chilled water valve is able to control as needed. So much better control. This is a really good example of the kind of a fault that you would never really be able to see this fault from somebody getting uncomfortable, because that cold air is going to go in and just get reheated. And most likely your occupants are going to feel just the same whether or not this is happening. So this is an example of, of where the software can bring to light these inefficiencies that are hiding in the system. Okay, the second example comes from BYU. They have a life science building that has a vivarium. So it's a really sensitive, critical space, a really important place to keep and maintain proper environmental conditions. And what we noticed here is that the air handler providing conditioning to this space was having a little bit of an erratic temperature. So this is the actual, pink line is the actual temperature, and the green is the set point. And as you can see at the bottom here, these little orange blocks represent the faults that were being detected by the software, showing that it wasn't meeting its discharge temperature and what's going on. So we brought this back to BYU and had a really good conversation. They have a really strong controls team who could dig in and look at the programming and discover that actually there were two set points when it was originally programmed that were fighting for control of this unit. And that was creating this up and down bouncing of that supplier temperature set point. They were able to go in and fix the programming, and you can see that where that line begins to even out. And we actually found out that the set point we have here isn't the set point they actually wanted, so that needed to be corrected later too. So that's why it's not quite meeting that set point we have. But these are all the things you have to kind of dig in and find out once the software points you in the right direction that there's an issue. So that's another example of a fault. Okay, so to make your analytics platform not just become another software that just sits in the corner gathering dust and brings no value, the most important thing is that your facility teams are able to get the items addressed through whatever means makes sense. It may take some thought about how to get the analytics results to translate into resolution. We have had the most success with clear, actionable reporting. We found that to be very useful. And this is an example from the University of Utah on reports that they receive for their air handlers. So this first page has a lot of really useful information about what the system is finding as far as leaking chilled water valves or leaking hot water valves, economizer problems, all of the things that they'd like to be aware of on their air handling units. And then the second page is a really well-defined list of actions that can be taken for each discrete fault or issue that's been identified. And so here there's just, and it's kind of small, don't bother reading it, but it's really like really trying to get at what are the steps that need to be taken to go resolve these problems in a really clear way. And we've also seen really excellent results getting things done when you can plug your monitoring-based commissioning program right into your existing workflows. So if you already have a work order or ticket system that you use to get issues resolved, this report can be put right into that. And then those issues can come to the people who are making the fixes in the same way that they get any other work order. And I will admit, it can be a little overwhelming to see the results from analytics. I think Josh and Jim can both attest to when you first plug it in, it can be very overwhelming to see all of the faults. And I think some of the really good advice I've had from people who have been successful with this is eat the elephant one bite at a time. Really just going through it and making, whatever small impact you can make. And over time, what we see is these MVCX programs reduce the amount of reoccurring issues in a building, which helps give the facility on the later side more time back. So it might take more time up front to work through, but then those reoccurring issues go down and you don't have to spend so much time. So it can be a real benefit in that way. Okay, I'm going to briefly touch on the two monitoring-based commissioning programs at BYU and the University of Utah. So this is BYU's program, a quick bulleted example. In 2018, they started with a 2-building deployment. And Jim's going to talk a lot about this one. It's a really great story. He calls it the bake-off. And this is where they decided how they were going to do analytics and really like their test case for their campus. And by 2019, they had over a dozen buildings integrated into the software, and they were actively finding and making resolution on those issues. And then in 2019, they took the extra step of using these tools, these monitoring-based commissioning analytics, to go through a recommissioning project, so enhancing that recommissioning project to get at deeper savings and then continue to monitor after that. And this year, they're applying that same method across 2 more buildings. So they're really expanding quickly in their program. And then the University of Utah started with their analytics software in 2014. After some major control upgrades, they decided to use those as commissioning and then monitoring-based commissioning tools on several major buildings across campus. And then in 2015, they did a really interesting maneuver where they've been doing campus-wide sub-metering and bringing that into their analytic platform. So when I said, you can do more than just data from your building automation system, you can identify data that's useful from other data sources and bring that in as well. And then in 2019, they did a big, rolled out a program across lots of their districts or facility teams to focus on 7 major buildings across campus. And they were able to achieve over $200,000 in savings with that particular effort and that program. And then this year, they've moved to a really focused effort across air handlers across all of campus. So all the major air handlers across campus are now being monitored and going through these steps of using the software, to drive their using the data to drive their decisions about maintenance on these pieces of equipment. It's really cool. Okay, and I'm going to turn the time over to Jim and then Josh, and they'll talk about their success stories as they've gone through this monitoring-based commissioning process.
All right. Hey, thanks, April. It's great to be here with everyone today, especially the U of U. We do have a fair amount of rivalry between our 2 universities, but it's been good to get to know Josh a little bit as we prepared this presentation. And there's lots to learn, even from rivals, and so it's been good to work with them. But I guess in my previous life as a controls contractor and doing system integration, I did have opportunity from time to time to do energy audits on buildings, but and it was obvious that there's a lot of improvements that can be made by looking closely at mechanical systems. I hadn't worked with any specific software previously, and so I wasn't too familiar coming into this position of which software would be best and what capabilities were out there. So shortly after taking this position, we had a meeting with our automation group here on campus, and to take a more serious look at what platform to use and if it would be worth doing, what type of software we'd want, and if the investment would actually pay off. I think for the most part, everybody in that initial meeting felt that it was worth it, that we wanted to at least do a test or try it see if things would fit. And so what I guess my presentation today would be kind of to go over how we picked the analytics platform that we're currently using. And we kind of started calling it our bake-off, which was kind of fun. I want to talk a little bit about kind of a little sidebar thing that came out of that, which was the automated functional testing. And then delve a little bit on the lessons learned, and then just briefly give you some results of our first big kind of full-on commissioning project that we did. Go ahead and go to the next slide. So kind of before we jumped in deep with analytics, we felt that we needed to figure out how could we really evaluate things? How would we know if it was working or not, and if we're making enough improvements to justify the cost? So we put together this kind of short list of criteria, and I think energy savings and not spending as much money on heating, cooling buildings and things like that was going to be the biggest piece of the pie. And so there was a few other things that we felt was also important, but or felt were important, but that energy savings was the biggest piece of that. And so the kind of the process we went through is we put together a loose scope for the project, and we tried to come up with what things would be good to test various analytics platforms. We only had about $50,000 to work with, and so that kind of limited the extent that we would do. So we picked a couple buildings that we felt would be the very kind of the best, the simplest, not to have a lot of complication. One of those buildings was older. It had a mix of kind of an engineering class and office space. And we'd use that building on a number of other things as a guinea pig building, usually control upgrades, things like that. The second building was newer. It was, I guess, 15 years old at the time, but it was still a fairly new. And that building was built to be LEED-like. Actually, it ended up being LEED certified and was one of the only ones on campus that we had. And we had done some energy improvements on that building after even that building was completed. And so we felt these two would be kind of a good couple buildings to use. I was familiar with a couple of the vendors in the area and the kind of functionality that they provided, but we also wanted to see if there was others that had some things we hadn't seen. And so we reached out to several, got some proposals, and took a look at things, and ultimately we settled on 4 different vendors to provide some solutions. That's kind of when our bake-off came up, because we thought, well, let's just have all 4 of them do the same 2 buildings. And then that way we really could tell which was providing the best bang for the buck. So the bake-off term came up, and that seemed to stick for the rest of the project. The one thing is that the 3 of those vendors had kind of different fault detection and diagnostic software. And the 4th vendor, who is our local integrator, had one of the same sets of software, but they didn't have quite the experience that vendor 1 on this table had. And so we kind of tweaked the scope a little bit and asked them to do something that was out of the box a little bit, and to come up with some custom automated functional testing routines based on in our Niagara front end. And so we use the Niagara platform across campus for most of our facilities. And so they agreed to kind of do that as a little different way. And so the top 3 vendors that you see here all had some different ways of implementing this analytics software. Vendor 1 came in fairly expensive, but also had kind of the most that they were offering. And we knew that we were going to get a variety of things from each. And so we felt it was important to see what it would be like having minimal support from a vendor as well as full support. And that played into kind of how we broke up and awarded these contracts. Also, we had the vendor 3 was a national kind of chain and provided something that we hadn't heard, but they were fairly inexpensive. And so we thought it was worth looking at them and giving them a try. So, so with that, I just want to do a little side note on our automated functional testing, since that kind of kind of grew out of trying to figure out what to do. So we gave that vendor 4 that task of coming up with some of these analytic kind of things, but doing it as a scheduled, routinely, kind of routine testing. And it evolved as we went along, but we were able to give them a kind of a scope, and we felt that kind of it gave us the ability in-house to use our staff and this experience they had, their training, and to outsource minimally. And we actually ended up starting to call this our SkySpark Lite version of analytics, because it didn't give us everything that the full-on SkySpark did. And so the nice thing is it led us along that ongoing commissioning path that we wanted to pursue, and it freed up our various mechanics and controls guys, so they weren't spending all of their time testing some of these things, and we could kind of automate it and just give them a report. So we did see some really good results from this, but they were limited. We saw kind of end of line type device reports, but we didn't see the big picture stuff. And so kind of here's on this slide, here's just a basic example of the scope we wrote for that functional testing that was then programmed into the software. And the nice thing about this is that the sequence went through, at least for a VAV example here, and it was able to, on a weekly or a periodic basis, test the damper actuators, discharge air sensors, velocity probes, and overall temperature control of the space. And so we did this at nights or on the weekends, so it didn't impact the tenants or the occupants of the space. And so it was valuable. But if we can go to the next slide, we decided to incorporate the results of this in our graphic. So that lower left portion of the screen, where it says self-test results, that was kind of our in-house programming that would return a result for that particular box. And then if you jump to the next screen, these results were color-coded and helped our mechanics to be able to see things really quickly, kind of indicating, the level of severity or the need to get on it really quick. And so it made it easy for them to visualize what was going on and we were able to use the same software that we were used to. From that, just kind of the overall thing as we come to kind of what happened with all this test, there were 4 or 5 main things that came out of this. One is that each of our providers or vendors, they found a lot of the same kinds of issues, and each provided varying ways of being able to see those issues. And so some were better than others, but they all came up with some of the big pieces. Each vendor identified something that the others didn't. They all had at least something that was unique to their platform that the others didn't have. The one thing that we struggled with and that we found pretty evident was that our in-house staff didn't have time to get spun up on any one of the softwares. We had 4 guys, and so it worked out that we could split them up to kind of focus on individual ones. But there was a challenge on any of them to come up to speed really quick. So it wasn't a few weeks to be fully versed in everything. It took several months for them to really get their hands around stuff. The one little hiccup in the whole thing was vendor 3 was acquired by vendor 2 partway through this whole process. And so unfortunately, the support for those 2 vendors dropped off significantly. Vendor 3 disappeared altogether. And so that, I think that impacted a little bit what the value that we got from those, but we still felt that through all of the efforts of all the vendors, we did see some improvements on the buildings, and we're glad we did what we did. When our bake-off was all done, we decided on using vendor 1 and vendor 4. Now, we hadn't initially thought we would use 2 at the end of this. We were just shooting for 1. But in the process of kind of spinning the automated functional testing off, we found that there was a little niche that it filled, whereas the normal analytics software took care of the vast majority of the big things and helped us to see the things that were going to impact the energy savings the most. The functional testing helped kind of more with the individual occupant comforts. And so we felt that that was still good to do, but we were set on that vendor one being for our main supplier. The things we learned from this was that our vendor assistance and all that they brought to the table at the varying levels was key. We had to have their help, support, and training. It just really was important. And with that, the buy-in from our mechanics, operators, and our automation guys, it was kind of correlated to how much the vendor was part of it. Because as the vendor was more involved, our guys felt like they got more, they understood more, and could do more with the software. The software platforms can be very complex, and it did take a while to get up to speed. We were able to see, though, that there are lots of things out there to be fixed, to be improved, and that they all, in some degree or other, can bring savings to the table. It's a lot to do at once. We found that these littler steps and doing small pieces before the big pieces definitely helped to make things more successful. And we absolutely felt we got what we paid for from vendor one. They did a fantastic job, and even though the investment was more, we felt it was absolutely worth it. So we settled on, like I said, vendors 1 and 4. And from there, we then were ready to, I guess, jump into our first real test. So with that bake-off behind us, we jumped into that next phase. And on campus, we have an extensive sub-metering program for all of our buildings. And so we were able to provide some good utility data, 15-minute data for years going back on a number of buildings to our vendor. And so they took a look at things, and we picked out about a dozen or so buildings that we wanted to deploy that fault detection and diagnostic software on, so that we could start to see what real things were happening. Our in-house team felt we knew which buildings we'd like to start with. And so we said, hey, let's do these 1 or 2. And then when we got our recommendations back from our vendor, they said, no, this other building, which is a newer building, is the one that you should do. And we're like, huh? So we were kind of surprised about that, but once we saw the data, it really made sense that that's where we should start. So the life science building was the building we chose. Pretty new building, fairly large, a variety of classroom, lab, and office space, a lot of outside air. So there was a lot of things there that we could do to improve the energy use just by reducing the amount of air bringing in from outside and having to treat it. You can jump to the next one there. So the measures that were identified that we needed to put in place were kind of the operation schedules. Our labs were set up with the original recommendations from the engineer. And so we went back and looked at those, and we're able to reduce some and adjust things so that they've still met all of the standards and requirements. We made some significant changes and adjustments to our discharge air and duct static pressure resets, and made those work together much better. And then we had some areas that were heating and cooling at the same time, and adjoining areas that were like served by several VAV boxes. So we were able to coordinate those and reduce that simultaneous heating piece. We had some hot water pumping differential pressure resets that were added where we hadn't had those before. And then we had found a closed fire damper that was causing air to backflow through a smaller ductwork, and that saved us quite a bit just from doing that one. So overall, the implementation, we were just under $250,000, which was a big gulp when I took that to our administration for approval and funding. But we showed them that we could do the payback fairly well, and we're on track for about $140,000 a year, and just under 2 years for our return on investment. So it's been an exciting project. So absolutely, they are definitely worth it, and would recommend you do something similar So we'll turn things over to Josh.
Thanks, Jen. So I'm going to talk about our S.J. Quinney College of Law building. It's a new building. It was constructed went into operation in 2015. And our cooling system at College of Law is a thermal storage tank. And it's not directly connected to a chiller. It uses a process where it has a mixture of irrigation water that's exchanged through a flat plate, and then a secondary tie-in to our chilled water plant. The challenge we had with this building is upon completion, we could never, during the summer months, recharge the tank to its full capacity during our off-peak hours, because that's when we're focusing on that effort. And that ultimately led to our customers being uncomfortable. Here at the university, we are on a decentralized model. So we have the districts, we have small teams, and a lot of people have been making efforts on trying to get the system working and trying to help it, but we could never really find the key issues. And that's where we use SkySpark and the ETC group to help us do a recommissioning of the building. ETC group, if you want to go to the next slide, helped us identify, these are our sparks from August of 2019. This is when I took over the building. These are our SkySparks from the month of August, and there's quite a few, and some are very high impact. When we started out this process, what we were finding is as we were moving through the building, we were very much focused on what you would think, because the thermal loop's not charging. You go stand in the mechanical room, you look for an issue in the mechanical room. And things like that made sense. Like the end switch is not functioning on this valve, so you go replace the end switch. This flow meter is not working, so you go replace the flow meter, things like that. And as we went further along in the process, we went further into the weeds, so to speak, or down the rabbit hole. And we were getting sparks on like zone occupancy, or this thermostat's not reporting correctly. And we found a lot of things like thermostats in the ceiling or in the wrong room, occupancy sensors that were wired wrong, frankly. We had a lot of little mistakes like that really were compounding our issue. One of the ways I describe it is the cascade of problems. We have this pile of problems that just makes it difficult to resolve the actual big problem. And buildings like this develop a lore and a bunch of stories about them. One of the reasons why people said the irrigation loop never worked is because they tied into the wrong size of line. And if you let that biasness dictate how you do your maintenance, you'll definitely not bother to go look at the irrigation loop. Oh, it's tied in wrong, so it can't work. And what we ended up finding out is one of the valves was just closed out in the street. It was tied in correctly. The supply valve was closed. So we opened up the supply valve and we were able to utilize the irrigation water. It took us about 2 years, and this last summer, very luckily, you see this is our most recent SkySpark data from August of this year. We have been able to recharge the tank fully overnight consistently. And this summer we've had more 100-degree days than we've had in a long time. And the building handled it perfectly. In fact, I was starting to get 2 cold complaints in the building during summer because we were doing that great of a job of meeting their needs. We had to go and teach people how to actually adjust their thermostats because they were actually too cold, because we had years of conditioning that it would never work right. One of the main ways we got about this was we used the process of data-driven decision-making. And you can see this slide up. It's a little brief about what the process looks like. So you gather data, you interpret data, you create a plan, and then you act on that plan. And ETC helped us filter through all the data points. Obviously, a building like College of Law has a lot of data points and a lot of opportunities that are being created from there. And data-driven decision-making allows us to exclude that biasness of all the stories that have been grown over the years of the system not working correctly, or relying upon a customer to complain before we actually act on it, and really allowed us to focus our efforts. One of the things that we used it for primarily was our zone occupancy lighting control system. It's tied into our HVAC, and we create a list, and I can send my electrician and a technician to those zones, those individual spaces, and say, this space is not following schedule. Please check the sensor and the associated relays. And we find all kinds of things that were done wrong or have just failed that we would have never have known, because I'm not here at 2 in the morning to know that the lights are still on. And that's where this type of process and this method of thinking really does help us maximize our efforts, because I have a small shop of 8 people and I manage 20 properties for about 1 million square feet. And if I didn't use decision-making process like data-driven decision-making or data-influenced decision-making, I would never have got this building to where it is today. It is the cornerstone of how we became successful in cooling our building down successfully and it operating correctly. And with that, that's all I have.
That's a great story, Josh. Thank you. What some of you in the audience may or may not know is that BYU and the University of Utah have a deep-seated long-term rivalry. I would venture to say there has never been a BYU and University of Utah co-presentation like just happened to hear outside of a football field. So I thank you guys for coming together civilly. And now I'll open it up to questions. I do see some questions in the chat, and I would encourage you to add your questions there, and we'll go through them for as long as we have time. Let's see, starting with one of the first questions was with regard to PID loops. And April, I think this might have been inspired by one of your slides. Can the systems tune PID loops on the fly?
That's a great question and a great point of clarification. So no, these systems are passive. They're not actually controlling your control system. They're just identifying, so for a PID loop, there are rules that can identify that the tuning isn't right. So it can identify that you're having too much overshoot and undershoot, but it won't make those fixes for you. Those still need to be executed through your controls team or controls vendor to get those things resolved. And we don't want them, you really don't want an extra software coming on top of your other software. Really, like, it's the right direction to make sure, you're not letting something else take control of your control system.
And the system can help the validity that the PID loop has in fact settled down. So that's another thing that the system can be used for. You can see that cycling has gone away once the PID loop has been adjusted by the controls vendor. That's a great question, thank you. Another question, what happens when there's a large system-wide event like a power outage? Won't that overwhelm the work management system? And I think what the person might mean is the FDD system. So what happens to the FDD system in an event of a power outage or some impact like that?
I can take this one if Josh or Jim don't want to. Okay, I'll take a stab and you guys can add to it. So it really depends on your system. And the hope is that you have an FDD system that's built upon important inputs to really make the result. So you want to make sure that you don't just have a rule that says if this and that, but you want it to be really smart and have extra things on there that say, well, look and see if that system's on before I flag something about that system. So if your fan is off, hopefully you won't see a bunch of sparks, coming through, or faults coming through that are telling you there's, oh no, you're not meeting temperature. It's like, well, the fan is off. Of course you're not meeting temperature. So you should have some things built in there to help prevent those cascades. But I do think that even in really good systems, that can still happen. You can still get some, kind of things that aren't quite right. But that's the hope, is that they're built well enough that you're not getting a flood when events like that do occur.
Yeah, and that's been my experience as well.
I was just going to say one other thing is that usually those events are fairly short-lived. And as you look at analytics, you're going to be comparing a certain day or week or month to another. And when those events happen, you can exclude those events from your comparisons to see if things have gotten better or worse.
Thank you, guys. Another question, can you give some examples of work management software that you've connected to and a brief description of that process?
So like work order creation?
Like work order systems that the FDD software is connected to.
We've connected it via our building automation guys. So as they see these sparks or things come through the fault detection software, they'll kind of prioritize them. And if they feel that they need to be escalated to a service request, then they add those in manually. We haven't felt that we wanted to do it automatically, just because the potential of thousands of service requests being put in and flooding the system would be overwhelming to the other guys that are taking care of some of those issues.
Yeah, we're in the same situation here. I think a good example of how many sparks you can generate is in College of Law. We're fully integrated, and I'm checking occupancy schedules most recently this week, and I generated 40 zones that I needed to have my technicians looked at. And if I had an integrated automated system doing that, it would probably generate that every single day, and your technicians would become blind to it, because there's a step that you should take prior to actually sending your technician out of doing a little bit of either the functional testing or some sort of backside looking, just to make sure that it's worth sending a technician, that kind of thing.
Yeah, I'll just add in just a quick little bit that there have been lots of instances of connecting in that work order system via a software like an API, so the two software can talk to each other. And exactly what Jim and Josh are bringing up is really important. If you do choose to do that, and eMaint is one example. I can't remember the names of the other ones, but I know we've connected to eMaint. And one really important, the most important thing is don't let it automatically do things, but make sure that there's some kind of human intervention to say, yes, I agree with this fault and I'd like it to be created into a work order, so that you don't have this flood for sure. So we have seen that happen, and with that intermediate step of allowing, people allowing or disallowing the faults to go through, I think is a really good way to do that. But I think most people are in the boat of they'd rather just be in charge of that, is what we find. Most people have chose not to go with that option. So it's possible though.
Early in the presentation, it was mentioned that the savings begins to drift. And what is the cause of this drift? Is it controls devices falling out of calibration?
Yeah, I think April probably sees more of this through what she does, but I think any building over time, things don't work as well. Mechanical issues come up. Occasionally you do see some manualing or overriding of certain devices, and that causes things to not perform optimally. And so the analytics can catch some of those where you may have somebody, it's a bad day, they manual something and forget about it because there's a bunch of other things that got them busy. And the analytics can kind of pick that up and say, hey, this valve is not working like it's supposed to be. And then you're like, oh yeah, we manualed that last month, and you put it back to auto. And so you don't get some of those things that get left for too long. Like our fire damper, we found that fire damper, and that was really, it came out of the image showing that our static pressure had switched from one of the fan systems to another. There's 3 of the fan systems in this building that run concurrently or share into the duct together. And one of them typically had been the lead, and after the fire damper failed, it switched to another one. And that was pretty obvious in the analytics, where nobody knew the difference because the air was still getting to where it needed to be.
I guess the other thing to add there is sometimes a failure in a piece of equipment doesn't just impact the energy use or performance of that piece of equipment, but it feeds back systemically. So a failure in a terminal unit can actually drive the way the air handling unit system is working if you've created a lot of the energy saving optimizations that are system wide. So little small failures can affect a big system. Another question, Jim talked about how he selected his MBCX vendor. How did Josh select his?
So I actually was not a part of that process. That was a separate group on campus that did that. When we switched to the district model, I actually became a manager of the custodial team for our district. And in 2019, I promoted into my current position. So I didn't have any hand in choosing the vendor or anything like that, but I'm sure it was a similar process.
Let's see, here's a question from the engineering community. The graphic for the law school still showed a lot of room temperature not met. How do you resolve that?
So the way we resolve that is identify why. Like Jim mentioned, there's a lot of people that go around and I say they like to help, and they make overrides, they make changes and adjustments, and things get out of whack. It's just like any other issue that you might have in a building. You might have zone temperatures not met because their computer is blowing against the thermostat, or they have something blocking the thermostat, so it's not actual following what the room is actually doing. And also with those, we drill into them before we deploy a technician to actually dig into the room, because you might find that that spark was created in a relatively short window on a single day, because that sampling might have been from a short window. If we spread that out and we see on average that space is fine and is able to meet set point more often than not, then it's probably not worth the effort and we should go focus on another thing. This building, though, is a kind of a unique system in more than one way. We have the thermal storage loop, like I said, but we also have active chilled beams. You can kind of see one behind my head there. It's not a VAV reheat system. So we have VAVs that then blow through the chilled beams, and then we either put hot or cold water through the radiator in the chill beam, and it cycles through like a little eddy current to then mix the temperature. So we have really slow reacting spaces because of that. It's a more passive, quiet system than a regular VAV reheat system. So there's a lot of factors that play into it. It's just like any other thing. You kind of dig into it and you look as to the reasons why. And 9 times out of 10, we find that someone put an override or was helping, and we found a lot of valves that had failed, or people taped the clutch shut so that it can't actually modulate anymore.
Yeah, one of the things you mentioned, Josh, that I thought was a really great takeaway is you talked about the cascade of problems. And I think that's an important thing to understand about this kind of analytic platform. Like sometimes you find the leaking valve that's costing you $30,000 a year. And other times it's a series of a little bit of everything that really contributes to resolving the problem. But it's the that can continue to help reveal. Another question from the audience, how long did it take to get the FDD system installed, configured, and running? Does the FDD system connect to your BMS?
For us, because we had three that were installed all at the same time, it was a couple months to get everybody, because there's IP addressing, VPN access stuff that had to be sorted out. And so once all of that and servers that needed to be configured, it was probably 2 to 3 months to get everybody really up and going and functioning. So.
And it does connect to your BMS.
Yes. Sorry. Yeah. We do have. I mean, it pulls data from our BMS into for histories and for points and things. And there's an onboarding process, and so those points are updated on a regular basis so that we have accurate histories that we can then use for trending and comparisons.
Other sensor systems that are feeding data into your FDD software besides the BMS, like energy meters or anything like that?
Well, our energy meters on campus feed into our BMS as well, And so we've kind of used that as the collecting point of everything. And so I think some of those could go directly to our analytics software, but we've chosen to kind of run it all through the one.
Mm-hmm. And Josh, I don't know if you can speak to the University of Utah about how long it took the system to get up and running since you sort of inherited it.
I did inherit it, but I know that it was a similar process. And like April kind of talked about, there's a lot of back-end work that has to happen for the system to function correctly so that you're getting relevant, actionable data, because that's the key. You could very easily whip together something and pull a bunch of data points in, and you get flooded with information that maybe not be relevant or actionable. And that's how that can definitely lead you awry, especially if you're trying to focus on data-driven decision-making. If you don't have relevant, actionable data and it's done correctly, it can really cause a lot of problems. College of Law is it's my only building that's fully integrated. I have several others that are partially integrated, and the partial integration didn't take that long. It was relatively easy, at least for me, because I didn't have to lift a finger.
Yeah, I was going to add, with the initial installation was the 2 to 3 months, and then as we've added subsequent buildings, they can be done in a day. Usually it's a few days once we decide and fund that project or whatever, but they go pretty quick.
I guess to add to that, the University of Utah campus has 3 controls vendors on campus. And so all 3 of those BMSs are integrated into the FDD platform. So as an FDD platform user, you have visibility into all of those systems. And in some cases, a single building can have different vendors in it. So it actually brings visibility about the whole building that you can't otherwise get.
Yeah, and you can view broader systems and the subsystems all in one page, where if you were in the BMS, you're switching between screens or you have multiple tabs open, and it makes it a lot cleaner to identify where you should focus your efforts, I feel.
Another question, how often do you report or track utility data? And do you monitor EUI to determine building review priorities?
So at the university, we do track our utility data because we're a state entity. We have to report that on a monthly basis, but that is tracked through our energy management group, and that is actually where a lot of this was born from. Was from them to help us be more effective and efficient in our energy usage.
And we don't have to report any of our energy use, but we've kind of had a long-standing need to just keep track of things. And so we do 15-minute interval data on electrical, chilled water BTU, hot water BTU, gas, sewer, basically all the utilities that can be metered. And we do that for pretty much every building on campus.
I think we have time for maybe one more question. I see there was a question about presenters willing to be contacted with questions in the future, and we would certainly welcome that. So please do. I believe Lily will send out that information after the webinar. Maybe the final question, do you see energy consumption improvements, or was the biggest improvement in occupant comfort?
I'd probably say both. My perspective going into this project is I really didn't care if we saved energy, because I had a building that had unhappy customers. And as you guys know, in facilities, we do our jobs best when people don't know who we are or where we are, because if we're doing our jobs right, they don't think about us that much. And this building, out of my 20 properties, was my second most expensive maintenance property in 2018. And 3 years old, with my average age around 80 years of life in the building, that's a pretty big number. That means we spent a lot of time here. But we did save quite a bit of energy by doing this project. And
at BYU, ours was, I think we saw some occupant change in temperatures because we had been doing some resets, but we've worked through some of those. And so the energy savings was the primary thing that we saw.
Great, thank you. One last question, is SkySpark BAS agnostic?
Yeah, I'd say so. You can use SkySpark with just about anything. It just depends on the integration ability of whatever system you're using.
Yeah, I have it on Honeywell, JCI, and Stafa systems. And I can switch in SkySpark. I can switch seamlessly between all those different buildings, and it works. There's no lag or no issues that I find. But SkySpark is just so happens that we both use it. It completely unrelated that we both use it.
Mm-hmm. Well, great. I think we are at time. I appreciate everyone's questions and your participation, and thank you to the panelists for sharing your story and how you've grown through the monitoring-based commissioning process and your successes. And April, thank you for sharing your introduction too. I'll turn it over to Billy to wrap us up.
Billy actually can't make it back in, so let's go ahead and wrap it up here. Thanks everybody for coming. Really appreciate the time.
Great, thank you all.